Okay, think about glass. We look through it every single day, we drink from it, our cities are basically built with it. But have you ever really stopped to wonder about it? How can something be so solid, and yet we can see right through it? It's a question that's hiding in plain sight, and today we're going to get to the bottom of it.
I mean, it's a total paradox, right? You can touch it, it can shatter into a million pieces, and yet light just sails through it like it's not even there. Well, to solve this mystery, we've got to start somewhere you might not expect, with a simple handful of sand.
That's right. The whole story of our crystal clear windows and phone screens actually begins right there, with one of the most common materials on the entire planet. So it all kicks off with two of the most abundant elements in the Earth's crust, silicon and oxygen. They get together to form silicon dioxide, which, in its natural crystal form, is what we call quartz. And those tiny, tiny grains of quartz are what make up sand. But just look at sand. It's totally opaque. You can't see through it. So what's the big secret? How do we turn this into a perfectly clear window?
Well, the first big piece of the puzzle has nothing to do with what it is, but how it's all put together. The magic trick that turns opaque sand into transparent glass is really a journey from perfect, rigid order into pure, frozen chaos.
See, inside a single grain of sand, all the molecules are lined up in this perfect repeating grid, what scientists call a crystalline structure. But when you have a whole pile of these tiny, rigid crystals all jumbled up, all those little edges and surfaces catch the light and just scatter it in every direction. That's why you can't see through a bucket of sand.
Okay, so to make glass, you take that sand and you crank up the heat. You get it so hot that it melts into a liquid. All that energy breaks the bonds and the molecules just start flowing around freely. But then, and this is the key, you cool it down really, really fast. So fast that the molecules don't have time to line back up into that neat, orderly pattern. They basically get frozen right where they are, all jumbled up in that messy, chaotic state.
So here's a look at the two side by side. On the left, you've got quartz with its ordered structure that scatters light. And on the right, you've got glass, an amorphous solid. Its molecules are trapped in that jumbled liquid-like state. This randomness creates a perfectly smooth surface on a microscopic level with no little edges to scatter the light. But here's the thing. Solving the scattering problem, that's only half the story.
Yeah, a smooth surface explains why light doesn't bounce off in all directions. But it doesn't explain why the light isn't just stopped, absorbed, like it is with a block of wood or a piece of metal. For that, we have to go deeper. I'm talking way, way in, down to the subatomic level.
So every single solid thing around us is made of atoms. And here is the most mind-blowing thing about an atom. It is almost entirely empty space. Just a teeny tiny nucleus right in the middle, with its electrons orbiting at what is, relatively speaking, a huge distance away.
To really get your head around this, picture this analogy. If an atom was scaled up to the size of a giant sports stadium, the nucleus would be nothing more than a single piece sitting on the center spot. The rest of it, all of it, is just empty space for a photon of light to travel through.
And that right there, that leads us to the real question, the one that flips this whole thing on its head. If everything around us is made of these atoms that are mostly empty space, then why isn't everything transparent? Why can't we see through a brick wall? This right here is where we find the true secret of glass.
The answer is all about a fascinating little dance in quantum physics. It has to do with particles of light, called photons, and how they interact with an atom's electrons. You can kind of think of it like a photon needs a very specific ticket, a gate pass, to get absorbed.
All right, here's how it works. Electrons can only exist in very specific energy levels or shells around an atom. To jump up to a higher level, an electron has to absorb a photon. But, and here's the catch, that photon has to have the exact amount of energy needed to make that specific jump. It is an all or nothing deal. If the photon has too little energy or too much, the electron just ignores it, can't do anything, and the photon just sails right on through.
And this, right here, is the secret of glass. The specific way atoms are arranged in glass creates a huge energy gap between the electron levels. It takes a massive amount of energy for an electron in a glass atom to make that jump.
So the photons from the light we can actually see, red, green, blue, all the colors of the rainbow, they just don't have enough juice to make that huge jump. They don't have the right ticket. The electrons in the glass atoms basically just let them pass. And so, billions and billions of these photons stream right through all that empty space. completely untouched. And that, my friends, is transparency.
Okay, but check this out. This is the really cool part. Higher energy photons, like the ones in ultraviolet or UV light, do have just the right amount of energy. Their ticket is valid. They get absorbed by the electrons in glass. And this gives us this amazing real-world proof. It's the reason you can't get a suntan through a regular glass window. The glass is actually opaque to that kind of light.
So when you put it all together, this chaotic molecular structure and this huge energy gap for its electrons, you get this incredible material that is literally, shaped the way we see the world.
I mean, just think for a second about what this one property has given us. We're talking about everything from the simple window that lets sunlight into our homes while keeping the cold out, to the powerful lenses and telescopes that let us peer into distant galaxies, microscopes that reveal entire worlds in a drop of water, even the eyeglasses that so many of us use to bring the world into focus. Our modern lives are built on seeing through this stuff.
And that's the final beautiful paradox of it all, isn't it? The most important thing about glass is that it's invisible. It is so perfectly designed to do its job, to just get out of the way, that we almost never stop to appreciate the incredible, mind-bending science that's happening every single time a sunbeam streams through a window. It's a solid you can't see that changed everything.